fact that he could use his resources.
The fact that he didn't, I think, is the thing that we should be modeling.
I like it. Or he cheated and still got a bad score.
That's probably more likely the answer.
No, because if he would have cheated, he would have done it well and got a good score.
Yeah, if I cheat, I do well.
That's not true at all.
Oh, it's our first warm-up of the year. Warm up. Go ahead. There's the 2 last problems from the class cake yesterday that 99% of us did not get to. So we're going to use that as our warm-up.
I already did those.
I already did these.
All right, do them again.
Oh, you're joking.
You're joking. What is 5.5? What is this? Like, what's the?
It's called performing function operations. Nice.
Then why is it about fractions?
Well, it's not really about fractions. Or fractions aren't involved. Also, while you're getting this warm-up taken care of, we are going to have our test on Friday. So there will be an in-class portion and a take-home portion of our test.
Oh, wait, so that means we can
What?
take it home?
No.
Yes. There will be an in-class portion and a take-home portion. The in-class portion will be on the new stuff that we've learned yesterday, today, and tomorrow. Wait, what day is it? Yeah, tomorrow. The take-home portion will be stuff you've already done. So I understand that take-home means, things that we were talking about that Cole did not do.
Yes.
Right?
Precisely.
Yeah.
So, I mean, hopefully you got some type of moral compass where you do your homework.
Are you coming over Friday?
Yeah. I'm coming over Friday.
Yeah. No, I'm not.
Yeah, no.
Good. Aww.
No, I'm not. But probably on Saturday.
You're playing Mario Kart
Olivia will be back.
Oh, can I sing?
No.
Trey likes Olivia.
Oh.
India.
Hey,
Hey,
come on, buddy.
that's more natural. Okay. First thing we should do is add one to each side so we can
You're
get
so
that.
funny, Levi. You just think you're a funny guy, don't you?
Multiply each side by 4.
Oh, with maybe the change.
And this is a cube root, so we should.
Hey, you're a funny guy, huh? Yo.
Let's see,
Oh,
number
nice.
6. First we need to divide by -3.
Yeah, that's what I did.
What happens when we divide by the by the negative?
Flip the sign.
Sign.
Flip the switch.
Flip.
I said we go to -5, and then we have root plus 2. Now we should square each side. Now x is greater than 23, so we check our
Yeah, that's what I got.
right here. Anything greater than 23 will work because we're going to stay positive inside the square root.
I like it.
Sweet. If you plug 23, I guess x has to be greater than 23, so plug 24 in for x. Wait a second, something seems wrong. Oh, but we're multiplying by a negative. So no matter what, we'll be okay.
Stay in positive.
Yep, we're going to be all good. Sweet. Questions on either of those? Okay. So, am I recording? Thought I hit record.
Yeah, you are.
Yeah, I am, because we were talking about using other resources on homework, and I got it all on audio.
Audio's in the video.
5.5, performing function operations. I think you guys have already seen before what we're doing today. I think. So you'll have to let me know if I'm taking it too slow. Students will be able to add, subtract, multiply, and divide functions.
I think we did this.
So here is like maybe you could say the complicated version of what we're going to do today. I'm going to go through one example of how we add, subtract, multiply, and divide functions. I'm going to give an example of each one. So I would probably recommend not writing this whole chart down and just writing down the examples. That would probably be more helpful. But this chart can be a quick reference point when it tells us to add. I mean, it helps us more with the notation. In parentheses here, when we have f plus g, that just means we're adding the function, right? Whatever sign is in the middle, we are just adding on to, or adding, subtracting, multiplying, or dividing the functions. This is not where, have you guys seen like f of g? Have you guys done that yet?
Yeah.
No.
F of G? Yeah, we've done that.
Where they tell you, like if f of x is this,
What does F of G or G?
right, where you have to plug.
But that's f of x and g of x. We've never done the.
Have you had to
Trey,
plug?
you remember
Never
that
done
assignment we
that.
did?
Yeah, I remember we did this
We did this in Mrs. Stone's class.
Have you had to plug one into the other?
We were in the same class.
Okay, so that is not to be confused. Well, if you don't remember, then I guess that makes it easy. But that is not to be confused with what we're doing here. Here we are actually adding the functions, subtracting, multiplying, or dividing. So we will look at some examples of those. At the bottom here, the domains of these different operations consist of the x values, just like usual. So part of what we're doing today is they will ask, what is the domain of this function? So our first example, when we are adding, let f of x equal that, g of x equal that, find f plus g of x. State the domain, and then evaluate the sum when x equals 4. So we're just adding them together. We have 3 root x plus negative 10 root x. Okay, I'll rewrite this in a little bit nicer. Two ways to look at this, and we've talked about both of them already. Since these are both root x, since these variables are the same, what are we allowed to do?
Combine them.
Right. So that would just combine to be negative 7 root x. Correct? No big deal. Another way, bless you, another way to look at it, in kind of the direction that the book goes into at times, is if you look at this term, 3 root x and 10 root x, what common factor do they have?
Square root of X.
Right, root x. So kind of where the book goes with it sometimes is you can factor out a square root of x, and then you're left over with 3 minus 10, and then you would get this. You'd simplify it to negative 7 root x. So you'd end up getting the same thing. Either way you think about it is okay. I like thinking about it in this way, right here, because I think, like when we have 3n minus 10n, that's really easy to see that we can just subtract them. But when we start throwing in like root x, or when we start throwing in like x to the 1/3 or something like that, I think it's easier to see this common factor, to factor it out, and then combine. So whatever way you want to look at it is fine with me. You'll get the same answer, but there's 2 different approaches or ways to think about solving that answer. Subtracting, I don't know if you can see that, maybe it's too dark, but on your iPad, subtracting, that's nice. 3x to the third minus 2x squared plus 5 minus our g of x is x to the third minus 3x squared plus 4x minus 2.
We did this last unit or try.
Really?
Yeah.
I don't.
Oh yeah, I remember this. I recall it.
This we actually
Okay.
Yeah.
Like,
Alright.
the last thing we didn't actually
We
do,
should
but
go
this
through
we
it.
actually did.
What do we need to do to get rid of those parentheses? They,
That you have to just distribute the minuses.
yeah. Yep, we got to distribute that negative sign. So, after we distribute the negative sign, 3x squared minus 2x squared plus 5. Now we're distributing negative x cubed plus 3x squared minus 4x plus 2. So all that. Now Now what are we allowed to do?
Combine like terms.
Perfect. Combine like terms. So we have a 3x to the third and a negative x to the third. That gives us 2x to the third. And we have negative 2x squared and positive 3x squared. So that just gives us x squared.
There's nothing for negative 4x, so that would just be 4x.
Perfect.
Wouldn't you have to?
Plus 5. What?
Isn't there a negative sign between or minus subtraction at the very top? Or did you change that?
No, he distributed that throughout the
Okay.
entire thing.
From here to here, all I did was distribute the negative. Did I miss something?
No.
Okay. And then positive 5, positive 2, plus 7. So sweet, we simplified it. Now in the last one, I won't go back and do it, but I forgot to state the domain and then evaluate at x equals 4. If we were stating the domain, could x be a negative number? Could x be 0?
Well,
Good.
well, there's nothing behind
Right. Square root of 0 is just 0. So it has to be greater than or equal to 0. And to find when x equals 4, what would we do?
plug 4
Plug.
in for x.
Yeah, plug 4 in for x. But we will do a better job with that here. State the domain. What do you think? What are our possible x values?
All
Or is there
real.
anything it could not be? That might be easier to think about. What was that, Aiden?
I said all real numbers.
I can't tell who it's called.
Levi.
Oh, okay. I knew it came from that direction. All reals?
You can put it on a calculator.
What are we trying to figure out? We have like the equation, but how do we know?
The way Levi says something.
There's no equal sign?
Yeah. How do we
I
know,
mean,
like,
Technically,
X?
this would be, I mean, if we wanted to, that's a good question. So we have, where is it? We're finding f minus g of x. A lot of times they will rename this something like maybe q of x. So we could say that this is like q of x. Does that make sense? Instead of calling this every time f minus g of x, they would just rename this whole thing something different, q of x or something like that.
Basically, we can, like, there's no under mechanics that we can do like that.
Right.
You got a snake.
Now, actually, somehow Levi brings up a good thing. That one of the things that the book brings out is that to find the domain, it could be really helpful just to throw it in your y equals. Okay? What they recommend doing is throwing in this original f of x and g of x. So throw in your y1 f of x and your y2 g of x. And then in y3, put in, I mean, if we call it q of x, but put in what you get after you subtract them or after you add them. So if you're struggling to figure out what that domain might be, just put it in your y equals. That can be helpful. If we evaluate this when x equals 2, we're plugging 2 in for each x value.
Isn't it negative?
Yes, that's what I meant.
Jeez.
No.
Okay.
This is wired.
There, 4, -2, plus 7. Let's see. -2 cubed would be -2 times -2 is 4. 4 times -2 is -8. -8 times +2 is -16. Plus 4 plus 8 plus 7.
Hey, really?
I think so. So we would get 3. Is that what I wrote down in my notes? Someone checking me?
Yeah, sure.
That's right? Alright.
Sure.
I'll believe it. I just need one person to confirm. Do we have any questions? Or is this pretty like, alright?
Alright. Let's get moving.
Okay. Multiplying.
Yay.
F of x is x squared. G of x is root x. We are multiplying them.
Just distribute.
Especially when we were multiplying, it's really helpful to write those square roots or cube roots or fourth roots or whatever they give you to write it as an exponent. Okay? So, are we allowed to simplify these?
No.
No.
I was hoping you'd say that. Yes, we are allowed to simplify these. They have the same base, okay? If they have the same base, then we are allowed to simplify.
Lie.
Now, what happens to the exponents? What do we do with them? We add them. Very good. So, what would be 2 plus 1/2? 2.5. But we don't like writing decimals in the exponents, so how do we need to write this?
2 and then 1 over
3 over 2.
Wrong.
No.
1.5. We don't talk about
That was pretty terrible.
that. Really bad.
Wait.
Yeah, that was pretty bad.
That makes sense.
Wait, so
Good thing we have the second and third row, otherwise we'd keep big trouble.
No.
I'm confused. Doesn't x squared times root x, doesn't it cancel and it's just x?
Yeah, x squared times root x.
Yeah, what if that just cancel out?
Yeah, that should just cancel out.
Yeah, it should,
Yeah.
it should
It
be
should be like
like
multiplying it, not
That's what I was
Yeah.
thinking.
Yeah.
Like, and then he knows
Come on,
math,
Mr.
so why would I not listen to what he said? You know? He's the teacher.
Yeah, see, but he's in contemplate.
Well, let's
Did give
think
us
for a
the
second.
wrong word.
I see where you're coming from. I'm trying to think of a good. It would not cancel out, no. But I'm trying to think of a good reason why. So let's put numbers in for it, okay? Let's say we had 3. Or 3, we can't take the root of 3. Let's say we had 9. So by what you're, I totally get what you're coming from, Jake, and I appreciate you bringing it up. But from that logic and what you're saying, that this should just give us 9.
Oh, so it'd be 9. So it'd be whatever 9. Yeah, 81. 2.
Right.
Okay.
Yep, it'd be 81 times 3. Does everybody see that? Or is that not?
So basically, if
I
you
see it.
squared the x that's already in the root, that's what it would cancel out?
Yes. Yep. Yep. Faith is asking, hey, we have a x squared times the square root of x. Why don't those just cancel out and give us x? Well, if we plug, say, x equals 9, which doesn't in this example, yeah, so we already did that part of the problem. Good job, everybody. If x equals 9, we would have 9 squared, which gives us 81, and the square root of 9, which is just 3. And I don't know what that is in my head. That's 163 maybe? No, it's gotta be bigger than that. Anyway, yeah, 243.
243.
So, they would not just cancel out. What would cancel out, like Faye said, would be this. This is what cancels out. Are you guys good? Good? Last one, dividing. This is the most trickiest.
We also
Why is
did this.
dividing?
I don't know. Good question.
So this chair has like
We have f of x over g of x. So 6x over x to the 3/4. If we remember way back to algebra 1 or 2 last week, Tuesday, what do we do with those exponents? So that would be if we were trying to rationalize the denominator, which is a good thought.
You have to subtract that.
Yeah, we can just subtract the exponents. Since the base is the same, we can subtract the exponent. So this is really just x to the 1. Oops, minus 3/4. Can you guys see that?
So it's 1/4.
So this would give us 6x to the 1/4. Since we have the same base, we can just subtract our exponents.
Bless you. Bless you.
To state our domain, what could this not be?
A negative.
It could not be a negative, because remember, the 1/4 would be like a fourth root. You can't throw a negative in there. So x would have to be greater than or equal to 0. And if we want to find the quotient when x equals 16, the fourth root of 16 is 2. 2 would give 12.
So if it is a negative, it's just no solution.
If what is a negative?
If the
X?
yeah. Or
Yeah,
not.
they said find it when x equals -5.
Yeah.
We'd say no solution. Now, we don't do that. We're not going to do that today. Well, or like ever, but good thinking. Okay. There's one slide on class kit.
One slide, let's go.
Let's go.
One slide, 2 worksheets.
Yeah.
One of them's a puzzle. Wait. One of them's a puzzle time though.
Oh, those you can look at.
Oh wait, that's already on that.
Oh, that reminds me. Make sure you show all your work on the puzzle time. Show your setup and then show how you simplify.
Can I just like write the rhyme?
No, you can't write the rhyme.
Can't just write the answer.